This is the second property of the alkanes, that they will also show these substitution reactions. So in substitution reactions, alkanes are being reacted with the halogens in the presence of sunlight. And the reaction which takes place in the presence of sunlight or light, that is the photochemical reaction. So the reaction can be explosive in the sunlight, but it will not take place in the dark because it is also a photochemical reaction. So light energy is needed to break the bonds in the chlorine molecule. So substitution reactions, chlorine atom takes the place of, so in substitution reaction, hydrogen is substituted by a chlorine atom, or you can say that the chlorine atom takes the place of the hydrogen atom. Now, this is the first member of alkane, CH4. If it combines with the chlorine, so the one hydrogen is substituted by chlorine, and you will get the halogen alkane, CH3Cl, and hydrogen chloride. If the sunlight is continuously there, so all the hydrogen atoms are replaced by the chlorine. The second product is CH2Cl2 and then HCl. So keep on doing these reactions. Ultimately, all the hydrogen atoms are replaced by a chlorine atom. Now, now at the start of the chemical reaction, there are four hydrogen atoms. Now, in the first, after first reaction, you have the three, then the two, then the one, and there is no hydrogen. Then the one chlorine, then two chlorine, three chlorine, and four chlorine. So one carbon is actually attached with the four different substances. If you add the number of hydrogen and carbon, 3 plus 1, you will get 4, 2 plus 2, 4, 1 plus 3, 4, and 4. So the first compound you may get is chloromethane. This is chloromethane. This is dichloromethane. First compound will be the monochloromethane. This is trichloromethane. And the last one is tetrachloromethane. So in substitution reactions, the hydrogen are replaced by the halogen. But this is a photochemical reaction. So photochemical reaction is that type of reaction which takes place in the absence, in the presence of light. When there is no light, no reaction. When there is light, then hydrogen atoms are substituted or replaced by the chlorine atom. Actually, the function of the light is that light is used to break the single covalent bond between chlorine and chlorine. And then when it breaks, the reaction is initiated. So for the initiation of the chemical reaction, there must be a light, and light helps to break the chemical bond between chlorine and chlorine, and then the reaction starts. Now, any alkane, like if we have ethane, if it reacts with the bromine in the presence of UV light, so this is the substitution reaction. So hydrogen are substituted by bromine. So the list of the product which you may get, that is number one, don't change the number of carbon atoms. Okay, don't change the number of carbon atoms. The carbon will always remain two, but hydrogen is substituted by the halogen, whether it is the chlorine or the bromine. Now, hydrogen, there are six hydrogen atoms. So if you replace one hydrogen atom, you will get C2H5. And then hydrogen atom is replaced by bromine. So this is bromoethane. Then you can get the next one. Just reduce the number of hydrogen atom and increase the number of bromine atom. you will get here 2 because there are 6 hydrogen atoms. It means that 2 carbon atoms, they are bonded through a single covalent bond, and there are 6 hydrogen atoms, they are also bonded through a single covalent bond. Bromine can also form a single covalent bond, so there must be 6 substances or 6 atoms. They may be attached with the 2 carbon atoms. So if you replace the hydrogen and add the bromine, 5 plus 1, 6, then 4 plus 2, 6. Then if you want to get the next compounds, keep the carbon constant. Now hydrogen, Br, hydrogen, then Br, hydrogen, then Br. Now reduce the number of hydrogen atom, you will get 3 hydrogen, then increase the number of bromine atom because 1 hydrogen is again replaced by bromine. Then there are 2 hydrogen, then against 2 hydrogen, there must be 4 bromines. Now, if you have 1 hydrogen, you must have a 5 bromine. And ultimately, if all the hydrogen atoms are replaced by bromine, you will get a product like this. So if you pick any compound, you can draw the structure of that compound. For example, if you pick this compound, there are 2 carbon, and because you are applying the general formula CnH2n plus 2, so that's why it is alkane. So if there are 2 carbon and 3 hydrogen atoms, so you can add these 3 hydrogen atoms anywhere. For example, if you add these 3 hydrogen atoms here and then 3 bromine here, this may be the compound. Or if you put 3 hydrogen here and then 3 bromine here, this may be the possibility. Or if you put two hydrogen, then okay, then bromine, bromine, then bromine, and then hydrogen. Now look at this organic compound. You have 3 bromine atoms, but all the 3 bromine atoms are on first carbon because you have a long chain of just 2 carbon. So we can say that this compound is actually 1, 1, 1 tribromo because all the 3 bromine atoms are on first carbon. So this is 1, 1, 1 tribromo, and the rest of the compound contains 2 carbon and then bonded through single covalent bond. What about this? This is 1, 1, 2 tribromo. This is 1, 1, 2 tribromo ethane. Okay, what about this? This is also, you can start numbering from this side because there are 2 bromine. So this is also 1, 1, 2 tribromo ethane. So these 2 compounds are same nature. As you can see that the molecular formula of these 2 compounds are same, but the structural formulas are different. So that's why they are isomers. And isomers are the compounds of carbon and hydrogen, which have the same molecular formula but different structural formula. So you can predict or you can draw the structure of any halogenoalkane, and you can name that if you have 2 carbon and 2 hydrogen and 4 bromine, so you can say these are the 2 carbon and then 4 bromine. You can attach 4 bromine anywhere. For example, if you attach 4 bromine here and then 2 hydrogen here, now the 2 bromines are on first carbon, 2 are on second carbon, so you can say 1, 1, 2, 2. 2 bromine on the first carbon, 2 bromine on the second carbon, but there are 4 bromines, so that's why 1, 1, 2, 2 tetrabromo, tetrabromo. And 2 carbons are there and single bond ethane. I hope you will uh, you will get the complete concept of alkane.